All right, let's continue. Given that we have already calculated the beginning amount, simple interest, compound interest, etc., we want to also show this relationship on the graph. So what we want to do is to put the amount with simple interest and the total compound interest, right? We're going to show it in the. So basically for year one, the amount with simple interest is 1110. For year two, that will be 120, etc., right? So we don't have to do this one by one, but rather we can just apply the equation all the way to year five, right? So it's going to be 110 to 115. You see the graph already show over the time how much money that we're going to have with simple interest. So this is the total thing because we also have the compound interest as well. So we want to also include what we call the total compound interest. For year one, the total compound interest will be simply zero, which means nothing, right? So there's no compound interest yet. For year two, the compound interest will be what we accumulate in year one plus how much we generate in year one, right? So that we're going to accumulate the compound interest like this. Again, we don't have to make the calculation year by year, but rather we want to apply this equation all the way to year five so that you can see the graph shows year one, year two, year three, year four, year five, okay, how much we get in addition to the simple interest and with the compound interest. So a good graph to show you the relationship between the compound interest, total interest, and the total amount that we end up with. All right, so now we want to move forward to do a little bit more fancy stuff. Okay, so we want to understand a little bit better, right? So we want to understand the question, what if, right? What if our investment will change from 0 year to 1 year to 3, all the way to 10 years? Right? We can generalize this into 20, 100 years. And what if the interest rate is 0% all the way to 20, maybe to 100 as well? So basically, this one basically says, what if the interest rate is 0% and the number of investment is 0 as well? So here is basically 5% interest rate for a 3-year investment. We want to know a little bit better. How do we do that? We don't know, but let's look at this all together. So let's assume we're going to make investment for $1 to make our life much easier. So we know we're going to start with $1 plus this interest rate, which is C3077. And we are going to make the investment for 0 year. Remember the equation, the future value here is for $1 is equal to $1 and multiply 1 plus R time of t, right? Which is ignore this $1 because it's just 1. So we're going to power of the time, which in this case is B78, right? So B78. If this is a year, if this is 5%, we are going to have this 1 plus this interest rate, okay, multiply power of 0, right? And of course, we can just type in the equation one by one from here all the way down to the right and to the all the way down. But we want to make it simpler because we know there's a simpler way to do that, right? So in order to understand better, so I want to make a little bit more calculation. 1 plus is 10% power of 0. And I don't want to make more because I think I know what's going on. So for this one, it's 1 plus the interest rate, which is C7 power of 1, right? So this is always what we want to do. If we want to apply the equation, but we don't know how, we can just start from a few cases, and then we want to get it started from there. But there's always one thing that we can do. There's a function called equal formula. Okay. I will show the formula for you. So I want to show the formula for this one, right? And I want to show a formula for this one, right? So we don't have to type in this. I just two more to the right. It will show the formula for this one and this one, right? And we want to show the formula for this column C78 as well. We can just write it down. So now we have the formula. I want you to see where's the commonality here. So let's start from this C77. To the right, it will change from C77 to D77 to E77. To the down, so 77, right? If you notice, what is changing is basically this from C to D to E to F, all the way to the right. But to the down, there's nothing changed, right? So we can fix this formula by, because we know 77 will be always the same, but C will change, right? What we want to do is to insert a dollar sign in front of 77 to fix this 77, right? So we always stay with this row. Another way to do that is simply press F4 once, twice, so you get another dollar sign in front of 77. It's the same thing, okay? And then we want to look at this B78. If you notice this B78, nothing changed, but when we apply the equation to the next year, it changed from B78 to B79, B80, etc., etc. So B will always the same, but the number will change, right? What we want to do is simply fix this B here, right? Or you press F4 twice. Right? So we get this one. So let's try whether our equation works. Because now we fix the equation, we can just drag to the right, go down, right? So basically, is putting the number and typing the equation one by one, we are able to calculate it for everything from interest rate 0 to 20, from number from 0 to 10. So we call this kind of formula, we call this relative self-reference, absolute versus relative. So the graphs here also show a table in this case. We are making the calculation for the future value of $1 for different time period for different interest rate. That will give us a better understanding. Like the longer, the higher future value, the higher interest rate, higher value for the future value as well.